Hello, and welcome to Backer Breaks It Down. In this episode, we will explore volume of cylinders. Okay. Granted, this little pizza cartoon kind of illustrates volume of cylinders. Okay, let's explore it, right? So here we have a pizza. It has a radius of z units, and it has a depth or a height of a units. Okay. Now, volume of a cylinder can be found just like volume of a prism. So let me revisit how we did that. Okay. So going back to Cavalieri's principle, if two solids have the same height and the same cross-sectional area at every level, then the two solids have the same volume. We found the volume of a prism by taking the area of the base times the height, right? Okay. For a cylinder, the area of the base, well, the base is a circle, and you can find the area of a circle by multiplying pi times r squared, right? So pi times the radius squared. So the pizza problem, right? Okay, so I can find the volume of a cylinder simply by taking the area of the base times the height. The area of the base can be found by going pi times the radius squared, okay? And the height, well, is the height. So here's our volume formula for a cylinder, pi r squared times h. In this particular problem, look at what they wrote. They said the volume is equal to pi times the radius squared. The radius is z, so z squared is z, right? Times the height, and the height is a. So volume equals pizza. Cute, huh? I know, adorable, right? So it's all about area of the base times the height. And since the base of a cylinder is a circle, we can specifically write a formula just for it. So volume is equal to pi r squared times h. So take a look at this cylinder, right? We've got an oblique cylinder. The formula volume equals area of the base times the height, or volume equals pi r squared h, applies to oblique cylinders as well as right cylinders. So we want to find the height of the cylinder shown. If the height is twice the radius, okay, so the height is, sorry, this isn't writing, 2 times the radius. That's what that says algebraically, okay? What's the radius? Excellent question, right? What do we know? Well, over here, they are telling us that, I don't know why I did that, the area of the base is equal to 64 pi centimeters squared. The area of the base, that is what is represented by pi r squared in our volume formula. So that means I know that 64 pi is equal to pi r squared. So I can totally solve this equation here for r. Notice that pi is on both sides of the equation. So if I divide both sides by pi, the pi's would cancel out. So now I'm left with 64 is equal to the radius squared. Okay, so what is the radius? You're right, the radius would be 8 because 8 squared is equal to 64. So I did have to take the square root of both sides here. So the radius is 8. The height is 2 times the radius. So that means the height is 2 times 8. So the height is 16. And now I can find the volume of my cylinder because volume is equal to pi times the radius squared times the height. And we now know all of those things. Okay, so volume equals pi times 8 squared times h, which is 16. I can multiply all those things together. If I go 8 squared times 16, I get 1024. Attach the pi because I haven't multiplied by it. Throw that into my calculator, and I get approximately 3,000 217 cubic centimeters for the volume of my cylinder. Taking a look at an application, this application problem involves density. Density in this particular problem is found by taking the weight divided by the volume. So I do need to know the volume of my solid in order to find the density. Now we're working with two wood logs that are approximately cylindrical. Based on the data in the table, which wood is denser, Douglas fir or American redwood? I first need to figure out what is the volume of each wood, and then I can divide weight by volume to find density, okay? So for the Douglas fir has a diameter of 1 foot. Okay, notice this is not the radius. So that means its radius would actually be 0.5 feet. Likewise, the radius for the redwood would be half of 3, so 1.5. So make sure you're using the radius because remember, volume is equal to pi r squared h. So you do need to know the radius. The diameter is twice the radius. Okay, so then I can go calculating my volumes. So the volume of that Douglas fir is going to be equal to pi times the radius squared times the height. And that gives me like 1.5 pi. I'm sorry, Douglas fir is sorry, you got that? Thanks. So 1.5 pi is the volume of the Douglas fir, and then I can calculate the volume of the American redwood the same way. So pi 1.5 squared times 4, and that gives me 9 pi. Okay, so these are the volumes. To get their corresponding densities, I need to go weight divided by volume. So for the Douglas fir has a weight of 155.5, and I'm going to divide that by 1.5 pi. And so I ultimately get 33. The weight is in pounds and the volume is in cubic foot. Do the same thing for the American redwood. Take the weight, divide that by the volume, and I get approximately 28 pounds per cubic foot. I don't know why it just crossed that all out, but it shouldn't have. Okay, so clearly the Douglas fir is the more dense because 33 pounds per cubic foot compared to 28 pounds. So the Douglas fir is more dense. Okay, the density when we're talking weight is weight divided by volume. Volume of a cylinder, though, just like volume of a prism, area of the base times the height. The base is a circle, so we are going to find the area of the base by pi times the radius squared, multiply that by the height. And that's how Becker breaks it down.